Indexes are a common way to enhance database performance. An index allows the database server to find and retrieve specific rows much faster than it could do without an index. But indexes also add overhead to the database system as a whole, so they should be used sensibly. PostgreSQL provides several index types: b-tree, hash, gist, spgist, GIN, and BRIN. Each index type uses a different algorithm that is best suited to different types of queries. By default, the createIndex command creates b-tree indexes, which fit the most common situations. B-trees can handle equality and range queries on data that can be sorted into some ordering. In particular, the PostgreSQL Query Planner will consider using a b-tree index whenever an indexed column is involved in a comparison using one of these operators: less than equals to, equals, greater than or equals to, greater than. Constructs equivalent to combinations of these operators, such as between and in, can also be implemented with a b-tree index search. Also, an is null or is not null condition on an index column can be used with a b-tree index. The optimizer can also use a b-tree index for queries involving the pattern matching operators like and tilde. If the pattern is a constant and is anchored to the beginning of the string, for example, call like foo% or call tilde foo, but not call like %bar. However, if your database does not use the clocale, you will need to create the index with a special operator class to support indexing of pattern matching queries. See section 11.9. It is also possible to use b-tree indexes for I like and tilde asterisk, but only if the pattern starts with non-alphabetic characters, that is, characters that are not affected by upper or lowercase conversion. B-tree indexes can also be used to retrieve data in sorted order. This is not always faster than a simple scan and sort, but it is often helpful. Hash indexes can only handle simple equality comparisons. The query planner will consider using a hash index whenever an indexed column is involved in a comparison using the equal sign operator. The following command is used to create a hash index. Gist indexes are not a single kind of index, but rather an infrastructure within which many different indexing strategies can be implemented. Accordingly, the particular operators with which a gist index can be used vary depending on the indexing strategy or the operator class. As an example, the standard distribution of PostgreSQL includes gist operator classes for several two-dimensional geometric data types, which support indexed queries using these operators. Indexes are special lookup tables that the database search engine can use to speed up data retrieval. Simply put, an index is a pointer to data in a table. An index in a database is very similar to an index in the back of a book. For example, if you want to reference all pages in a book that discusses a certain topic, you have to first refer to the index, which lists all topics alphabetically and then refer to one or more specific page numbers. An index helps to speed up select queries and where clauses. However, it slows down data input with update and insert statements. Indexes can be created or dropped with no effect on the data. Creating an index involves the createIndex statement, which allows you to name the index, to specify the table, and which column or columns to index, and to indicate whether the index is in ascending or descending order. Indexes can also be unique, similar to the unique constraint, in that the index prevents duplicate entries in the column, or combination of columns on which there's an index. PostgreSQL provides several index types: b-3, hash, gist, spgist, and GIN. Each index type uses a different algorithm that is best suited to different types of queries. By default, the createIndex command creates b-3 indexes, which fit the most common situations. A single column index is one that is created based on only one table column. A multi-column index is defined on more than one column of a table. The basic syntax is as follows: createIndex, index-name. On table-name, column 1, column 2 name. Whether to create a single column index or a multi-column index, take into consideration the columns that you may use very frequently in a query's where clause as filter conditions. Should there be only one column used, a single column index should be the choice. Should there be two or more columns that are frequently used in the where clause as filters, the multi-column index would be the best choice. Unique indexes are used not only for performance, but also for data integrity. A unique index does not allow any duplicate values to be inserted into the table. The basic syntax is as follows: create unique index, index-name. On table-name, column name. A partial index is an index built over a subset of a table. The subset is defined by a conditional expression called the predicate of the partial index. The index contains entries only for those table rows that satisfy the predicate. The basic syntax is as follows: createIndex, index-name. On table-name, conditional expression. Implicit indexes are indexes that are automatically created by the database server when an object is created. Indexes are automatically created for primary key constraints and unique constraints. Example: the following is an example where we will create an index on company table for salary column. Hash createIndex salary-index on company salary. Now let us list down all the indices available on company table using /d company command. #/d company. This will produce the following result, where company key is an implicit index, which got created when the table was created.